Tools as a Service is a research project and an engineering implementation done by CAS and Center of Excellence for Research in Adaptive Systems. The lead researchers on the project were Marin Litoiu, Hamun Gambari from York University, Johnny Wang and Tao Zheng from University of Waterloo, and Gabriel Ishlai, Joanna Eng from IBM Center for Advanced Studies. The project started from two major observations. The first one, installing and configuring software development tools on desktop is a very tedious process. It requires machines with enough memory and disk capacity and with enough computing power. And usually you don't have those in a university environment where you have to find specific labs where you have to install the tools, because otherwise they won't work. You need to install, configure, and update the tools for each desktop, and you have to do it very often for every lab and for every course that you teach. The second major observation is that to use the tools, the developer or the student has to be in front of his computer all the time. Due to the licensing constraints, the IBM development tools have to be used on campus only. Students cannot install them on their laptops or access them from home. To eliminate the drawbacks of running the tools on desktops, we set the following goal: to develop a solution in which the development tools are made available as services and access over the internet. That will eliminate the installation at the user end. That will eliminate the requirements for special hardware. It will make the tools available 24 hours a day, 7 days a week, and the tools can be accessed from everywhere. To provide the tools as a service, we had to overcome the following research challenges. The first one was the seamless installation and configuration of the tools. In other words, it means automatic provisioning of the tools on demand. The second challenge was the security and performance. Security refers to the integrity and privacy of data, and that's especially important when the data produced by the tools is sensitive IP of the company. With regard to performance, the use of the tool over the internet has to give the feel that it runs locally. In other words, the performance degradation has to be minimal. The third challenge is the data separation and consistency. That includes data in and data out. Running a tool remotely and saving the data remotely should also allow the user to suspend and resume sessions and not to lose data. Similar to running the tools locally, the user should be able to move data around, especially when working in a team and when collaborating with other developers or students. Finally, the service has to produce cost savings. In other words, it has to consume less resources, less energy, and less system administrators. The solution we came up with is a private cloud that offers the tools as a service over the internet. The cloud has the following architecture. At the very bottom, we have a storage layer where we store the user data and the binary of the tool. The binary of the tool is also called a virtual image. At the middle tier, we run the virtual machines, and each virtual machine is made of a virtual operating system and the binary of the tool that we want to offer as a service. At the very top, we have a session tier that includes a network load balancer. The role of the balancer is to evenly distribute the load between different virtual machines such that the response time observed by the user is within specific limits. An usual scenario will work like this. A user using his laptop or any workstation logs in to a portal. The credentials are verified by an LDAP server, and eventually the user is allowed to log in. Then the user can ask for a specific tool, and that tool is automatically instantiated as a virtual machine. And in the same time, space is reserved on the storage for user data. After a while, and after working with the tool, the user might log off. In that case, the session is suspended, the data is persisted on the storage, and then all the resources are freed for other user to use. Tools as a Service was officially announced on February 18, 2009, and it was a result of a collaboration between OCE, IBM CAS, and the following Ontario universities: University of Waterloo, Queen's University, University of Toronto, York University, and Carleton University. The service was installed on two clouds, one belonging to the Center of Excellence for Research in Adaptive Systems, or CERAS, and the other belonging to IBM. The users of the service include students, professors, and other researchers of CERAS. It also includes IBM Canada software developers. And next, I would like to invite you to watch a task demo.
Sam is a software developer who occasionally does UML modeling using Rational Software Architect. He does not want to install RSA on his office computer, but he does want to use RSA as a tools as a service over the cloud. With the browser on his office computer, Sam clicks the bookmark that links to the site that provides tasks. He logs on with his user ID and password, and after he is authenticated, he is presented with a list of tools that he is entitled to. Sam clicks on the RSA icon. Behind the scenes, a virtual image of RSA is being provisioned for him. He uses RSA to work on his UML instance, but he has to stop now to visit a customer. So, he saves his project and workspace, and then logs out. In the evening, after he goes home, Sam wants to continue working on his UML project. Sam uses VPN and logs in from his home computer. With his browser, Sam clicks the bookmark and goes to the task site. He logs in and selects the RSA icon again. His saved project and workspace is being restored for him. Now he can continue working on the project that he started earlier in the day. All he had to do was visit the task site, log in with his user ID and password, and choose a tool, either Rational Software Architect or WebSphere Integration Developer. He does some work in it, saves it, and logs out. He can log back into tasks and see the last workspace that he saved and continue right where he left off. With tasks, Sam can work on his software development projects anywhere and anytime he wants, without worrying about carrying his data and his workspace on one machine with him all the time.